Hello and welcome to Database Management Systems. I'm Jovita Christie, and in this video, I'm going to explain to you schedules in transaction management. So let's begin. First of all, we'll see what schedules are, and we'll see an example of a schedule. So consider this transaction. This transaction is a transaction T1, and here you can see there are two variables, A and B. And what this transaction does is it reads the value of A and then subtracts 50 from it and writes the same value back. And then it reads the value of B and adds 50 to it and writes it back. So this is a very simple T1 schedule, and I've used this in the previous videos also. So you can think of a scenario where A and B are accounts, and so this transaction is actually transferring the amount of 50 from A to B, because from A it is being subtracted and it is being added into B. So this is one transaction. Now I have another transaction, which is transaction T2. And in transaction T2, what is happening is there's a 10% deduction from A, which is then added to B. So if you look at the transaction, you can see that T2 is first of all reading A, and then it is taking a temp variable where it is storing 0.1 times A, which means it is storing 10% of the amount in A in a variable temp. And then this temp variable is subtracted from A, but it is also added into B. So once again, T1 is transferring 50 from A to B, and T2 is transferring 10% of A from A to B. So these are two transactions. Now, if both transactions have to take place or execute simultaneously in my system, then I need to provide a schedule for them, which is almost like a timetable, where I can tell which instruction, which operation will happen first and which operation will happen next. So that is how you can create a schedule. So in transaction T1, these are all the operations available. And what will happen here is these operations will be executed one by one. But from here, the operations that I need, the operations that are most important are the read and write operations, because those are the only operations where the memory is being used. In other operations, the memory is not being used. It's just a calculation. And so we'll only extract the read and write operations from T1. So what you can see here is read and write operations of T1 extracted from T1. And now let's bring back T2, and we'll do the same with this one. We will extract the read and write operations. So what you can see here is the T2 transaction with read and write extracted. So what we get now are two transactions, T1 and T2, with only their read and write operations available. Everything else, which was the calculation part, is removed. Now we can arrange these into a schedule, into a timetable. So there are several ways of doing that. One such way is simply creating a schedule in this manner. So what you see here is there is a transaction T1 and transaction T2, and T1 is first going to perform read A and write A, both operations. And then after that, T2 will perform read A and write A. Then again, T1 is performing read B, write B. And then once again, it is T2's turn to do read B and write B. So this is what a schedule looks like. And before I proceed further, let us now define a schedule. So schedule is nothing but a chronological order in which instructions are executed in the system. So a chronological order is basically an order where you specify what is first, what is second, what is third. And that's what we have done here. So you can see in this schedule that both the transactions are happening simultaneously. And that's why this is known as a concurrent schedule. But there is also a way of having a serial schedule. A serial schedule is a schedule where one transaction happens, and once it's over, then the second transaction happens. So let's take a look at it. This is one serial schedule where the transaction T1 happens first, and once it is fully finished, only then transaction T2 starts and does its work. So you can also have another variant of this where transaction T2 happens first and then transaction T1 happens. So this way you can have serial schedules where one transaction takes place after another transaction. Obviously, concurrency has its own benefits, because imagine if you were actually using such a banking system where only after one transaction is over, you can perform another transaction. Then you would have to wait for somebody to finish their transaction in order to do your own transaction. So this serial schedule is possible, but this is not what is done in practice. In practice, we use concurrent schedules that we saw earlier. Now let me define what a serial schedule is. So a serial schedule consists of a sequence of instructions from various transactions where the instructions belonging to one single transaction appear together in that schedule. So whenever you have sequence of instructions of one transaction appearing together in one schedule, then it is known as a serial schedule. So all instructions are appearing at the same time together, then it is a serial schedule. And that's it for this video, and I'll see you in the next one. Thank you for watching.